Okay, so this video will show you more of examples on finding the limits. The first one in our set of exercises is we want to find the limit. Of x squared minus 16 over x minus 4 as x approaches 4. Remember that the first option that we can apply here is we use the substitution method. So if we will do that, so the limit will become 4 squared minus 16 all over 4 minus 4. So this is equal to 16 minus 16 over 0 or 0 over 0. Now the problem is we can't say that the limit is 0 over 0. Actually, we call this value 0 over 0 indeterminate. We don't know the real value yet. Okay, so that's indeterminate. Okay, so how do we find the limit then of x squared minus 16 over x minus 4? So obviously substitution failed in this function, but the thing is substitution method is not the only method in finding the limits. For some expressions, when you get the limit and the substitution method will fail, one thing that you can do is you simplify the expression. So when you look at x squared minus 16 over x minus 4, they're somehow related. We know from basic algebra that x squared minus 16 is the same as x minus 4 and x plus 4. And if you look at it, the denominator contains the factor x minus 4. So rewriting the expression, so if I want to get the limit as x approaches 4 of x squared minus 16 over x minus 4, so one thing that you can do is to simplify any of the expression if you can. And obviously we can simplify x squared minus 16. So this is the same as limit, taking the limit as x approaches 4, x minus 4, x plus 4 all over x minus 4. And then from here we can cancel x minus 4 and we are left with x plus 4. Now in this part of the solution we can already use the substitution method. Remember, if I want to get the limit of this, I can do that by just simply getting the limit of x plus 4, and that is 4 plus 4 equals 8. So the limit of x squared minus 16 over x minus 4 is actually 8. Okay? So again, just to summarize what we did here, when we use the substitution method, we ended up with 0 over 0. That's indeterminate. We don't know the limit yet. So one option that we can do is we simplify the expression. Usually you use factoring to simplify it. It depends on the expression. Here we can try factoring. We tried that, x minus 4 and x plus 4, and we found out that we can cancel some of the expressions. So after simplifying it, this expression is actually equivalent to x plus 4. So if I get the limit of x plus 4, that means getting the limit of x squared minus 16 over x minus 4. And that is how we got 8. Okay? Now for letter E, unlike letter D, if you look at E and F, this is 1 with a minus sign on top here. And on letter F, you have 1 and then you have a plus sign there. So what do these signs mean? This 1 minus symbol means you're getting the limit as x approaches 1 from the left. Meaning, if this is the number line and this is the number 1, your x is coming from the left as you approach 1. That's the meaning of x approaches 1 with a negative sign. In the same way, as x approaches 1, then there's a plus sign there. It means you're approaching 1 from the right of 1. So these are the numbers bigger than 1. Okay. Now, Taking note of this, let's go back to this one first, letter E. We want to find the limit as x approaches 1 from the left of x plus 2 over x minus 1. Now note, substitution method can be applied in finding this limit, except if you will get something that is like 0 over 0. But if we try substitution, the limit is 1 plus 2. So take note, I'm changing x by 1. 1 plus 2, 1 minus 1. And this is 3 over 0. Which is, we know that this number does not exist. Or sometimes we name it as undefined. Okay? Take note how this 0 over 0 is different from or to 3 over 0. So this is indeterminate. If you have 0 over 0, any non-zero number in the numerator divided by 0 will be undefined. Okay, so these two are different. Okay, in this case, we don't need to simplify the expression because clearly the limit is undefined. But an undefined can have two possible options. It's either it tends to go to negative infinity or it tends to go to positive infinity. So the question now, whenever you get something or a limit that is undefined, definitely it will be an infinity. It approaches infinity. But which infinity? Will it be the negative infinity or the positive infinity? How can we know which one? Okay, now going back to the given expression, we want to get the limit as x approaches 1 from the left. Okay, so meaning you are taking values of x that are smaller than 1 because you're coming from the left. All the numbers here are less than 1. So to determine what will be the sign of your infinity, because definitely this will be infinity, you select a number very close to 1. Okay, but it should be at the left of 1. Say 0.9999999. Okay, as many 9 as you want. Just to make the computation simple, let's pick 0.99. Okay, so if this is 0.99, so this is also 0.99. This is 2.99, and this is negative 0.01. Negative 0.01. So meaning, when you divide these two numbers, you will come up with a negative number. So this sign actually will be the sign of your infinity. So as x approaches 1 from the left, the function goes to negative infinity. In the graph, this will look like if you have x equals 1 here, x is not defined at 1, so it means it will become a vertical asymptote. So as you approach 1 from the left, your graph goes to negative infinity. So your graph is going down lower and lower and lower, and it approaches negative infinity. That's the meaning of this graphically. Okay? But algebraically, to find the limit of this, if you will end up with a number, non-zero number over 0, it will be infinity because it's undefined. But if you want to know, and of course you want to know whether it's positive or negative infinity, you select a number that is very close to 1 and then you substitute it to the x. So you divide that number, but actually you don't need the exact value. But when you look at it, this is positive 2.99 over negative 0.01. The value is a negative number. Okay, so since it's approaching a negative number, it means it should be going to negative infinity. Okay, now to make that clearer, let's take letter F because this is exactly the exact opposite of letter E. Same expression, but this is approaching 1 from the left and this one is approaching 1 from the right. Okay, so we already know that you will end up with 3 over 0 by the substitution method, and you know that this will go to infinity. But will it be positive infinity or negative infinity? How will you know? You select a number from the left, or on the right rather, of 1, very close to 1, say 1.01. So imagine if this is 1.01 and this is 1.01. When you add the two, this is positive. When you subtract the two, 1.01 minus 1 obviously is 0.01, so it's still a positive number. And you use the rule of signs. Positive over positive is positive. So that sign will be the sign of your infinity. So as you approach 1 from the right, your graph tends to or is approaching positive infinity. This is your positive infinity, this is your negative infinity. Okay, so I hope that is clear. Now, in letter G, you still have x plus 2 over x minus 1. But this x is approaching the 1. Okay, if you recall, in finding the limit as x approaches a number, you have to check the limit from the, when you get the limit as x approaches 1 from the left, and the limit as x approaches 1 from the right. If the values are the same, then that will be the limit as x approaches that number. Now, we already did that to E and F. 1 from the left is letter E, 1 from the right is letter F. And the result of letter E is a negative infinity. The result of letter F is positive infinity. So they're not going to the same direction. Okay, so the limit of this does not exist. But you cannot conclude whether the limit is really positive infinity or negative infinity. Okay, so they're not the same. So these two are not the same. So the limit does not exist. You simply say the limit does not exist. D and E does not exist. Okay, but in some cases, now what if this is positive infinity and this is positive infinity? Now if that will happen, then the limit for G still does not exist, but you can conclude that it is positive infinity, because from the left and from the right are going to the same direction. Okay, in the same way, if this is negative infinity, the answer to letter E is negative infinity, and the answer to letter F is negative infinity, then the limit as x approaches 1 is also negative infinity. So again, only if the two are the same, then you can conclude what type of infinity is for the limit. Okay, so but in this case, we saw that the limit as x approaches 1 from the left is negative infinity, and the limit as x approaches 1 from the right is positive infinity. Therefore, you cannot conclude anything about the infinity, so you just say the limit does not exist. Okay, so these are 4 more examples on finding the limit. The first one is by, you need to simplify it. This one you have to understand, analyze, limit a number from the left and a number from the right, and so on. Okay, so that's it.